Hello. In the context of evaluation of agroecological development potential through transnational cooperation and entrepreneurial innovation, I would like to keep presenting new elements related IoT, data science for farming optimization. And we'll keep presenting elements about water quality, first of all, remote sensing, and some elements of data science. Thinking about irrigation systems, water quality is very important. And controlling and content analyzing of the water, it's very important about the quality of the production. Some pollutants, like heavy metals, must be considered as the major contaminants that are presented in water supply. And these kind of elements are very important, threaten the health of millions of people worldwide, normally associated with cancerous and non-cancerous health risk. Thinking about this kind of pollutants, it is very important to measure the quality of water and taking into account reduced concentration. The measurement on site it's very challenging and involve a complex setup. We would like to present some of the important parameters, metrics that characterize water quality for agriculture, and here we can mention total dissolved solid, conductivity, salinity, and sodium absorption ratio. As we can see here, some criteria must be considered, and we have here elements such the values, the concentration, for instance, in the case of total dissolved solution, values less than 400 milligram per liter are considered no effect. But thinking about other parameters, we can see the values of conductivity that till 250 milligram per liter is considered at good quality, but increasing this conductivity is considered the very middle or very low quality. Also the salinity, we speak about 0.2, that it's a good quality, and we can have different ranks, A, B, C, D. At the end we have very low quality when this criteria imply that salinity is over 1.5. And sodium absorption, it's also considered in three classes, three ranks, A, B, C, and it's an important water quality parameter. Thinking about water for irrigation and the salts in water for irrigation. All the waters used for irrigation include some salts, and salinization of oil and water is inevitable in climate where we have less precipitation. It's very important that salts and irrigation are key to sustainably irrigated agriculture. In the case of arid and semi-arid climates, that is the case of Portugal, where the quantity of water is quite reduced. In the last year we have actually very low quantity of precipitations. The salinity can be defined as total salt content we have here some parameters that can be considered. Electrical conductivity that can be used to express the salinity, and we have elements of units that are used to obtain the electrical conductivity, usually Siemens, and total solid dissolved solution solids, that it's milligram per liter or in ppm. So dCT is another parameter that express the sodium content, and we have here a way to calculate, where very important is sodium absorption ratio, defined like we have here different ions like calcium, magnesium and sodium, and based on this we can extract information. It is very also important to know the values of pH. For in this case we have acidic or basic or alkaline. It's and we, based on the TDS, we also can classify the water. Excellent, where TDS is less than 1, and we have 1000. After this we have good and permissible, and when we have more than 2000 it's unsuitable. Okay, where electrical conductivity, it's also like parameter, it's a very important parameter, and we have here also some limits associated with excellent, class 1, good, class 2, permissible, and doubtful and unsuitable. Okay, the salinity impacts are different. Is more related to the physiological part of plants, increase osmotic potential of soil, specific appear like specific ion toxicity, can conduct to leaf burn, and also can be associated with nutrient uptake interference. Here we can see for different type of plants, for crops, the soil salinity and yield impact in percentage. We can see for different type of plants, let's say corn, we have here the corn that can be affected by actually higher salinity measured by electric conductivity, and we can see that regular values less than 4 or 5 are actually very interesting for big part. When we think about less than 2, big part of this kind of crops are present high productivity, while if we increase the salinity, this will decrease specific behavior. It can be observed in some of like wheat or barley. Okay, that it's actually they fit well with higher salinity. Here we have also some elements about the relation, the SAR, that's its sodium ratio, and different sodium hazard in water, and we have here a set of SAR values, different region of SAR values, and the condition of the water. And in the case of low sensitive crops must be cautioned, and so on. And we can see also the importance of the usage of this kind of additional elements that can manage the higher values of sodium in soil. But let's move to the more important pollutant. Here we have a list of heavy metals. Some of them are more zinc, cadmium, and lead are very with affect chromium. They affect so much and can result in significant toxic impacts. This concentration is related to intensification of agricultural land and the usage of different technological solutions that have led to heavy metal pollution in soil. The evolution of heavy metal can be carried out on-site or off-site. Off-site involved the transportation of water, probes, and analysis in the laboratory. It is not so good solution, taking into account the time and also the cost and the quality. The more interesting solution is based on-site heavy metal monitoring or analysis of the water, and in this case we can speak about specific sensors associated with different, let's say, acquisition, embedded processing, and communication system that are part of IoT monitoring system for water quality. Here we have some elements, the heavy metal and the source dependence, and we can see that natural, agricultural, industrial, domestic, and other type of let's say activities can affect the concentration of heavy metals that can appear in water that later is used for irrigation. What is the main impact? We have reduced soil fertility, modified microbial and population processes, modified carbon mineralization, and so on. And that means, in some words, we can see also that directly can affect the plants, the induced oxidative damage, anomalous genetic behavior, modification of signaling and cytogenetic pathways, abnormal reproductive response. That means all together will conduct to reduced crop production. We can see that one of the source of these heavy metals in soil and in water come from fertilizers, from pesticide, from biosolids and manure, wastewater, and other atmospheric deposition. When we speak about fertilizers, we can mention here phosphate fertilizer, nitrate, like more important. And when we speak about pesticide, we have herbicide, insecticide, and fungicide. That actually it's all of the category of pesticide that are used in intensive agriculture. For this reason, less intensive agriculture and less pesticide will conduct to less heavy metal in water and soil. We mentioned here some of the heavy metal like copper, zinc, cadmium, lead, or arsenic. Arsenic is very, very tough problem in some of the countries, especially in the big country with the big important necessity for high production. We speak about here, like an example, the India, where they have actually big problem with arsenic, and they are trying to purify waters, trying to improve the quality of water, because arsenic is very harmful for health of the people and all the plants. What we have here, we have some type of fertilizers, nitrate fertilizer, phosphate, ferment, compost, and so on, and we can see the pesticides normally affect the concentration of lead, but thinking about, let's say, nitrate fertilizer, we have also impact of chrome, nickel, lead, zinc, and cadmium and lead. That means it's very tough problem, very difficult problem. Thinking about measurement, I would like to mention here that the concentration of heavy metals is quite reduced in the order of ppb, parts per billion, part per million. It's very high concentration that immediately can harm the plants and harm the people that consume this kind of plants, or the water is very toxic. But ppb is enough toxic, however it's very difficult to measure. And here we have a classical solution also associated with heavy metal measurement. We speak here the usage of electrochemical workstation, that normally it's a potentiostat, that the measurement is based on 3 types of electrodes: working electrode, reference electrode, and counter electrode. Functionalization of working electrode is very important in order to perform accurate measurement of heavy metal. As we can see, the system provides an information. The computer can control the potentiostat using different type of wide communication, and the results are mentioned and are presented on different type of graphical use. It's true that big systems are for laboratory, and as I mentioned before, this involves to take the water in some specific recipients and go and prepare and for some preserve in some specific condition, and later to be analyzed. However, taking into account the precision agriculture concept, in situ of heavy metal measurement is very important. You can save time and even money making this kind of measurement. And here we actually is presented another solution that is more compact, and as we can see is like a mobile phone based solution, where we have a specific sensors that are we speak of printed electrodes or nanosensor, and this kind of sensor actually continue to include 3 types of electrodes: reference, we have also working electrodes, and we have also counter electrodes. We speak about 3 lead electrochemical cell that actually is materialized for this kind of sensor. We have here the sensor that include all these elements, and at the end this computation platform that also include a display It's can be considered also like let's say like embedded computation platform. We can include actually a potentiostat, but also it includes some elements related communication. We have here mentioned the Wi-Fi module that assure the connectivity with remote database, remote information system. Another solution here presented state HMO1, again portable potentiostat with Wi-Fi capability, communication capabilities, and we have here like type of heavy metal. We speak about lead, cadmium, and we have some specific range for both of them. You can see here quite low values, an interesting measurement range for in situ measurement. Related nanosensor printed electrodes technology, we can see here some solutions that can improve, are represented by single sensors or multiple sensors. And here we, with multiple sensors, actually we can extract information for different type of heavy metals that are presented, that exist in water, and we can even characterize in global way the quality of that water, taking into account the pollutants existing in water. We can see here some electrochemical testing and methods, and what we have here, there are some techniques of voltamperimetry, and we speak this kind of methods are strongly dependent by specific electrochemical detection technique. We have voltammetric, amperometric analysis. We speak here, we have a cyclic voltammetry that is commonly applied and was applied also by our group when we are testing different kind of solution of printed electrodes. The high absorption capability of carbon-based working electrodes that are one of the common solutions. It's very related to recognition elements and are to be capable to extract information from different heavy metals or about different heavy metals presented that are presented in the water. To increase the detection limit, we speak here about different techniques. Signal amplification by chemical or electrochemical catalytic reaction can be used. And another important parameters that are commonly used in the water and soil is the pH measurement. For the soil, pH represents an important indicator, acid, basic, or, and we have pH monitoring. It's related also the evaluation of agroecological potential, and actually the punctual in one part of the land where we want the surface that is analyzed can be performed with some commercial solution. However, it's important to mention that pH is very important when we have distribution for, let's say, agricultural surface. For this reason, sometimes we have the system that relate the pH with GPS. We speak about geographic information system applied for precision agriculture. Together pH, we can measure different other parameters like in soil, nitrogen, phosphorus, potassium, NPK, sometimes temperature, pH, and moisture. That is also very, very important for the farmers, related the capability of their remote sensing. It's using the sensor. Sometimes it's very interesting, but it's focused in some specific region, and it's very difficult to have an information about extending region when we speak about hectares or rather even tens or hundreds of hectares of some culture. For this reason, to have information about some of the important parameters of soils, including moisture or other kind of parameters, the remote sensing become an important solution. This kind of remote sensing can be performed, can be classified in ground remote sensing, aerial remote sensing, and satellite imagery or remote sensing based on satellite. And we can see here one of the idea to one of the image of different obtaining using remote sensing. We'll start to speak first about ground remote sensing. Are based on optical system mounted on the level of agricultural machinery, on tractors and other kind of machineries, and based on this information we can have an information about some of the parameters of the crops or soil when the machinery is passed through that region. One of the commercial solutions that it's can be mentioned, like one of more important in the field of ground remote sensing, is GreenSeeker. That is from Timbo, and they provide some solution, the optical system, mounted on vehicle, and overhead irrigation allowing high resolution field imaging with minimal operational cost. It includes the own light source, that it's actually red and infrared, near infrared, 660 nanometer or 900 400 nanometer, and make some measurements independent by the sun angle. That is very, very important. We can see here the block diagram of this kind of system, provided that it's named GreenSeeker, that it's actually an active sensing system, actively generates light in red and near infrared, and this light is reflected from target, the crops, and are actually these reflected waves are used to perform the calculation of normalized difference vegetation index, named like NDVI. Thinking to ground sensing, plant stress has been estimated by spectral signature, and we can consider here passive and active sensors. And active spectral sensor minimize the illumination effects by producing their own illumination which is reflected from the target. It's very important that we become the measurement are independent by position of the sun. And we have here, based on this kind of system, NDVI, this parameter that was mentioned before, it's dependent by in some way illumination intensity, target temperature, and other parameters like relative humidity. But let's see this kind of system work. We have ground remote sensing on the machinery, but also we can see the manual usage of this kind of system, and with a specific power supply. It's true that it's for specific case, some illnesses or some case of like this. Usually this system, the green seeker, is mounted on the machinery, like here, and we can see exactly how it works. As I say, here is mentioned only one length, wavelength, but actually where it works on infrared and red wavelength. The NVDI, normalized difference vegetation index. We can see here the calculation that reflectance in the red band, reflection near infrared band, and based on this we can see that actually 800 nanometer was used for near infrared and 670 nanometer was used in this particular case for red light. We can see that this NVDA is also related to evaluation of different parameters of the plants, especially nitrogen uptake and plant health. Thinking about NVDA and these very important elements related to plants, we can see here a set of plants, and during the year how the NVDA is variation of NVDA in time is presented for different months, and we have some of the plants can have a NVDA very low index, but during the July, August, September, October, this value can become very high. And this is land remote sensing, but let's have an idea about area remote sensing, or the remote sensing based on the usage of drones. Remote sensing implies the use of camera, different kind of camera, visible camera, thermographic camera, hyperspectral camera. When we have a hyperspectral camera, actually we can include different spectral bands, and for every this spectral band we can extract information, additional information. The big problem in this case is the huge quantity of information and how this information can be transmitted and processed in time, in order to have positive application or positive impacts on the production. Here we have actually one of the case where we have some agriculture land, and where the drone is taking some image related different type of image. We have combined infrared camera, red, green and blue light imagery, RGB that is name, and also very important to extract normalized difference vegetation index, and based on this to have information about development of particular culture or crops. Crops monitoring in a remote way involve sometimes, as I mentioned before, multispectral camera. Usually we speak about 4 bands, starting from visible till near infrared region. In precision agriculture, multispectral camera can collect information about green biomass and process of determined with age of monitored plant. And we have here some example of this kind of camera. Now every day we are looking to our mobile phone that include more than one camera. We speak about the latest version of mobile phones. The idea of different camera actually is used also in remote sensing, area remote sensing. And here also I would like to mention the thermal or thermographic camera. Seems like usually it comes also with RGB camera, but it's very important that extract information about heat, distribution of heat. That means at the end of the day we can extract information about water stress in different plants. The resulting image looks in colored way, but actually this because it's only a representation of different level of temperature. Usually depend of palette, but usually the like blue or black represent low temperature, or the colors red, yellow represent higher temperature. Normally this image cannot be visualized directly by our eyes, but it's a code of representation of this distribution of heat on the field. And according to the type of measurements, the camera can be adjusted to measure the temperature between imposed limits. Here we speak about calibration and image processing. That means we have temperature, but we have here values between 35 and 67. The calibration can be done especially in laboratory, but it's very important that if we want to relate some characteristics of the plant, some stress factors on the field and thermographic image, we need also in some conditions to perform independent measurement in the phase of calibration on the field. And this is very, very important. We have here some of set of image that characterize different situations. One of them, water deficit in crops that induce a stress. It's water stress, that it's also related to low production. The deficit stress toward water deficit stress is very crucial, and for this reason, based on monitoring using remote sensing, especially thermographic or other kind of camera, I mentioned also hyperspectral camera, we can extract in time this information, and we can act to improve the quality of plants, the condition for better plants with higher quality. And now we are going to another type of remote sensing. Usually it's related to satellite. Specific, we have here Sentinel-2, come from Google, that provide multispectral and hyperspectral image associated with the evolution of crop, growth, and farm management, considering a large spatial and temporal scale. That means at the end we can specify some region where we are interested in and to extract information. What is very important is that we can have a global image for increased surface of land. However, there are some limitation related to the quality of image during the day, and for this reason we have here some satellite imagery for precise different application. This kind of Google imaginary, they provide some API to develop their own solution and to perform the analysis of imposed region. Let's say that can have here some information about Sentinel, that it's actually the way that this software is working in relation to the satellite. We define actually the region. Based on the defined region, we can extract different parameters. You can see here, and we specify, and now we have even possibility to apply some type of filters, and also we can save this kind of image. Remote sensing can be also used to extract information about vegetation infested by insect pests. That means we can apply in time the pesticide. Satellite monitoring also is strongly related to rational fertilizing, and based on the information about the stress, nutrient stress or water stress in different crops. The remote sensing can be related to the fact that assure lower carbon signature, considering decreasing of consumed fuel, considering the optimal management of operation. That means we don't need so much operation on the level of the fields, because we can apply in specific region. The data that is obtained from satellite is very, very important, because the management can be optimized using techniques, data science techniques. Also, thinking about satellite imagery, we have some detection problems that was mentioned before. The vegetation in these techniques to map the vegetative density on the respective farm sometimes, and we have also possibility to extract the information like vegetation density, and can also some image can be extracted, can be processed to extract information about the pest or disease. More biggest challenge of satellite imagery is to that require skill. In this moment, the software is very basic and involve the necessity to develop specific sensor analyze software to extract accurate value of different type of stress, like water stress, nutrient stress, and so on. We have here actually thinking about strengths and drawbacks. We have a comparison between three types of remote sensing. That we have ground remote sensing, where we speak about some optical system with camera connected to the machinery, okay? And we have here information, some strengths like easy to measure, are available, high resolution and low cost. We have on the drawbacks part, small monitored area, the diagnostics. This is the drawback because actually we can visualize a specific region, and if the machinery will not go around all the specific region, actually we have very limited information about that field, agricultural field. Thinking about aerial remote sensing, we have high spatial resolution. It's also important that we can use different type of imageries. It's accessible, still accessible, and have a moderately low cost. And here, like drawbacks, weather condition can influence, because necessity certificate to fly, because we know very well that the drones are not must be receive the certification to fly in some region, and also the limited fly height, yes, and also the autonomy I can mention additionally, and by comparison with ground remote sensing. Satellite imagery, free image with some satellites, free API, that is also very important, is related to software development. And the big strength is we can have the information for a large area. But we have also drawbacks. Related clouds may influenced collected data. We have clouds normally. High cost for some image with high resolution. It's actually we are dependent on satellites, where we cannot have our own satellite. It's very expensive, and sometimes this kind of services are very expensive. And also we are dependent on the data accessibility. That means in sometimes the service provider cannot give us the data that we need. That means the image that we need at that time. And now we are going to the other specific field. It's related to data science. That means we have data from sensor for different kind of sensor, and here we can see a set of data source, okay, and also we need to extract more information from this data, and that will be useful for farming optimization that require a deep knowledge of the business and also sound information to sustain decision making for problem solving. And related to data science, we have nowadays technology, very important technology on data collection, data storage, data analysis. All of this data collection, we speak about different sensors on the field, deployed on the field, but also we speak about remote sensing, as was mentioned before. We have here related data science. We have contribution from different scientific areas like statistics, computer science, information science, and mathematics. We have actually data science it's a big interaction between data analysis, traditional software, and machine learning. For the particular case of data science in farming, it's this kind of let's say data science tools can help farmers, scientists and manager and technician to optimize yield, improve the quality and crops quantity by making better decisions concerning the time when seeds may be planted, when pesticide, insecticide and fertilizer have to be used, and in what quantities, as well as crops may be harvested. And that means all this information coming from sensors in different way is stored, is analyzed, and give the verdict, give the let's say possible decision for the farmers. About farming technology are used to assess soil condition and to provide information about fertilizer requirements, water availability, the relation between wind and, let's say, water stress, let's say, and also extending the farming concept to the manufacturing transformation of plants and other farming products. Data science may be used in predictive analysis, time-based and usage-based fault prediction, and preventive maintenance of farming manufacturing equipment, demand forecasting on inventory management, price optimization, and at the end product development. We have here actually an interesting diagram where we have the inputs, okay, the farmer, pre-harvest, farming, post-harvest. It's important that the farmer can use the technology for sorting, reduce it wastage, and control it storage. This is on the side of farmer. We have the figure of processor aggregator that at the end define procurement standards and synchronize procurement with production plans. Actually, here it's very important that the farmer must provide also good quality products that satisfy good quality production that at the end will satisfy the processor, but also the distributor and retailer. And at the end we can have information when we prepare, when we interact with production, which are the acceptance of different kind of products, that it's related to user habits, and measure the nutrition. We have also data science application working continuous process loop. We have here actually starting from sensors that are collecting raw data, store the data, clean some data that are not accurate, and apply some algorithms like machine learning to provide reports that help farmers to take decisions. We don't speak that machines are taking the decision, but machine can give an advice to the farmers to make the right decision. Thinking about data science, we have here a set of, let's say, data science technologies, including machine learning, and here I can mention artificial neural network, support vector machine, decision trees, random forest, that are frequently applied for agriculture management purpose. And we have here actually artificial neural network and random forest and so on are here presented. Big data are information assets characterized by high volume. That means big data appear when we have huge amount of source, yes, including sensor, and that deliver for long period information about, let's say, water quality, soil parameters, and so on. Big data come from high resolution remote sensing technique. As I say, also the satellite remote sensing involve remote high resolution. Smart information from satellite or weather station, it's also can be related to big data. And what is very important is to have the possibility to process the big data with specific machine learning algorithms. Thinking to the important methods and the remote sensing and data science applied to remote sensing. Some examples are related to satellites monitoring of crop conditions. And here we have a block diagram associated to deep learning techniques on imagery. Yeah, that means we have here satellite image. We have here a set of learning networks, including feature extraction, and at the end we have classification, object recognition, and sense understanding. What we saw here, yeah? Thinking about deep learning, actually it's like a neural network with increasing number of hidden layers. How we can integrate different technology on the farming infrastructure. We can see here that it's a big interaction between different solutions. We have field measurement sensor, wireless sensor network. We have also the communication part, the cloud side for analysis of the data, and we can, based on this, we can transform the agriculture, more optimize it, and more competitive. We speak about optimizing the farming supply chain process requires a systematic approach to business process management, and we have here a diagram of process identification, process discovery, analysis, redesign, implementation, monitoring and controlling, and actually this is optimization steps of the farming supply. Specific case, we speak about rice culture. Rice is important Portuguese farming product. We can see that there are different regions where this product is used, it's cultivated. This will be actually the third part of my presentation, where I will mention specific cultures associated with Portugal agriculture.
Wet rice from seed to harvest process. Amazing modern agriculture technology. This mini tractor, although has a small appearance in comparison with other traditional tractors, but it actually holds the capacity of bulls. It comes with a comfortable size with a plow attached at the back, which not only assists in the balancing of the fields, this tractor is particularly designed for plowing purposes only. Other than this feature, it doesn't disrupt the balance of the land because of its special machinery plow. It's designed with a complete cover that doesn't let the sand disperse, but remain at the same place when the plowing process is being carried. This ultimately helps the seeds to get well mixed with the land that ultimately results in the best growth of the crops. Now, before going further, I'd like all of you to please subscribe to our channel and press the bell icon to get notifications and updates regarding important videos on our YouTube channel. Rice plantation. With the assistance of 2 workers, this machine carries the minimal plants of rice and grows it in the land with a greater balance. The workers are only supposed to place the trays of the plants at the back of the machine that escalates it downward by sending it to the plower. Then the plower, which comes at a rotary function, fixes the plants in the land. Additionally, it's built with thin and flexible tires which never devastate the conditions of the land, and it can easily function in the land which is watered. As the plantation of rice is carried in wetland, especially with a great level of water present in it, and this is a crucial element to be carried for bestowing perfect growth to the rice seeds. Other than utilizing such types of machinery, it would be a hectic process to carry the plantation of rice plants if this was carried manually. Agricultural Wonder Drone. This is something seriously crazy. A helicopter that floats above the plants to carry out the watering procedure for them. It roams above the surface and sprinkles water on the plants so that the minimum watering requirements are met for their perfect growth. It is basically designed with a tub attached at the bottom with 5 sprinklers that sprinkle the water. It all needs one worker who's supposed to operate the helicopter by remote control. It can cover a wide range of area until the worker's sitting within the range of the control sensors where the mini helicopter can catch its command. Rice harvesting. Moving in a straight manner with plucking each plant of wheat and oats. This is what's made by the organization which is known as Yanmar. Its operations are very smooth, and the machine itself is very friendly and easy to operate. It's not made with tires, but instead it comes with crawlers which can make its movement more flexible and easier. It entails only one worker who operates the machine. The attached plucker at the front pulls the plants and sends them to the escalator that in a balanced manner passes them to the main body, which saves the seeds and threshes the leftovers by spreading them on the field. Additionally, its speed is very much optimized, which can cut several fields within hours that ultimately saves more time for the farmers. Similarly, at the last of the operations, the giant trunk throws the seeds in the truck. The overall process that was supposed to be carried by a series of workers is being carried by this truck only. Thanks to the manufacturers for helping the farmers out there and making their jobs fun too. Cam Colvin. The manner of operations is as the same as Yanmar as you watched about, but the only thing that differentiates Cam Colvin is its size and the modes of operations it carries. It has a rotary plucker attached to the front which covers a wider area than its actual size. It has a slower speed than Yanmar. The best part of this tractor is that it can hold the seeds in its bucket that's placed and made on top of it. Similarly, it also spreads the plants left over on the field as Yanmar does. As you can see, the other tractor, which is manufactured by CAT, runs faster than Colvin, but each of them is perfect at their point and area. It's expected to take some time, as Yanmar does, because it covers more area and plucks more plants at the same time as Yanmar. No doubt, each of them is harnessing the farmer's potential to carry their job with fun and enjoyment.